Now I'm going to show you how to service an outboard motor, and to do this we've picked on this little Johnson 4. This is very similar to all two-stroke outboard motors, with the exception the components are lighter and it has less of them. A bigger outboard motor, for example a Mercury 90, may have 3 carburetors instead of this engine's 1. The gearbox will be much heavier, but other than that the features and the way it works is much the same. This particular model, as you can see, is really quite beaten up. It's had a good hard life. Half the transfers are missing. The front cowl latch has been redesigned by the customer because the standard latch has a nasty habit of falling off into the sea. We'll remove the cowling first of all, and then we'll have a look at what's under the hood. The first thing I'm going to do is to remove all the items that need servicing on the outboard. That will include the fuel pump and the carburetor, the recoil start mechanism, the underwater unit so that we can look at the water pump. To do this, the first thing that we actually do is to get access to these components. And on this model, we'll be taking off the 2 halves of the lower apron and the cover from the leg. When you're removing various components from an outboard motor, the lower pans especially need some care. There are several items that connect this to the main body of the outboard motor. There's a fuel hose which needs removing from a plastic spigot on the fuel pump. These are quite tricky to remove and great care must be taken. The trick is to use the flat edge of a screwdriver and gently push it off. At the front of this little cowling was a choke knob and a starter button. The choke knob on this particular motor is simply pulled out firmly and it becomes disconnected from the choke lever. On the outboard itself, you'll see that the stop switch is still connected. They can be left in place like this, but care must be taken not to crash this if you spin the motor. Here's the choke knob that we removed. It's simply pulled off the shaft with a firm tug. The items I'm going to remove from this motor for servicing are the fuel tank, the spark plugs, the fuel pump, the recoil start mechanism and the carburetor. These are the parts that I've removed from the motor for the service. First of all the fuel tank, and the things I'm going to check on this are the cap and the seal. An easy way to do that is with the air screw locked. There's a little bit of petrol in there. Does it leak? No, that's sealing quite well. If you undo the cap, you need to undo the air screw and have a look for any blockages under the air screw that could be stopping the little vent hole from working. Before we refit this, I shall empty the old fuel out of it, put a rag in, push it round with a screwdriver to absorb all the old fuel and any pollution that may be in there, and that then will be ready to refit and have fresh fuel fitted. When I took this off the fuel pump, you'll see that I've inserted a punch to stop the fuel in there pouring out all over the floor. The spark plugs we'll be looking at. You can see there's carbon deposits on one of the spark plugs, but that's not bad. For a 2-stroke, that sort of running is to be expected. You'll get some discoloration. We won't be using these spark plugs, we'll be fitting new ones. The gap on these spark plugs should be checked with feeler gauges, but they normally are preset from the factory. We'll strip and have a look at this little fuel pump. When I remove this, the hoses that go onto these spigots are removed with great care. These are very delicate and easy to break. This is the fuel line with a little filter installed. These are quite expensive, these filters. I happen to know this is almost new, this filter, so we'll flush this through and reuse this one. The recoil start mechanism, we'll pull the cord out, then we'll inspect the root of the cord, and that's in perfect condition. cord on this engine can be reused. The spring is working very smoothly, and all we need to do with this is perhaps wash the old grease off and put a little bit of fresh grease on the groove at this point here. It can be seen that the starter pawl is in perfect condition, so this recoil doesn't need a great deal of work done to it. This is the little airbox from this engine. It has quite a complicated little plastic mechanism and requires great delicacy when taking off. These parts are very easy to break, so you really need to be quite light-fingered with this item. Here's the carburetor. This is what mixes the air with the fuel. We'll be taking the float bowl off and having a look inside to see if there's any muck in there, and to check on the float height and the condition of the float valve. Attached to the carburetor is the carburetor cam. This is the little roller that is pushed. That in turn pulls up this little lever, which opens up the carburetor butterfly. Again, on this motor, the peculiarity is that this piece of plastic can have a tendency to crack at the bottom of the U-bend, so we need to inspect that quite carefully. This one's in very good condition. It will be noted there's a little washer here. I find these frequently missing from motors where they've dropped off on removal and haven't been replaced. That's quite an important little item. And the next thing we'll do is to remove the gear case and inspect that. First job is to remove the propeller. With some side cutters we can fold back the split pin, tap it out, and pull it all the way. Then we pull the propeller off the shaft. This particular engine just uses a split pin to hold the propeller in place. Most other outboard motors will use a nut at the end of the shaft. Once you've got this propeller off, you'll see inside the propeller we have a plastic hub. If you push a punch through there, you can push that hub out and inspect it. Not all outboard motors have this device that's so easy to remove. We can have a look at this. It's a little bit mucky. I'm going to check it for cracks. It's not bad. We'll give that a clean and that'll go back in. Inside the propeller is a rubber sleeve. I need to have a look at that for cracks or any signs of damage. If there is, we'll replace it. This one's okay. The propeller shaft itself has a shear pin inserted through it. That drives the outboard motor's propeller, and you need to look for any kinds of damage to that pin, and you need to make sure that it's straight. If in any doubt, replace it. Now we'll remove the gear case. When you're doing this on an outboard motor, you need to check on how the gear case is connected. This particular motor has two bolts underneath. There is a shaft that runs down the leg of the outboard motor to operate the clutch or the gears. There are a variety of methods of undoing this shaft. Some motors will have a rubber grommet in the leg here, underneath which will be a connecting block with a bolt. Other motors use a shaft that simply slips on top of another, and they're quite easy to do. This particular motor uses a one-piece shaft that goes through a hole in the casting and presses against the spring in here. There's actually nothing for us to undo on this model other than the two bolts. So we'll tilt that up, and now we'll undo the screws. And to remove the gear case, we just grasp it firmly and pull. Out she comes. That's the little shift shaft. That has left a hole in this gear casing down here. If you turn this upside down now, oil will run out all over your foot. We can see the drive shaft has a little bit of rust on it. We can clean that quite easily with some wet and dry. There's the water pump mounted at the bottom of the drive shaft. And that's ready for us to put in the vise and service. At this stage, it's a good idea to check on the operation of all the items around the saddle assembly. We need to grasp the engine and see if it swivels nicely inside the bushes. If there's overdue friction there, we might need to remove these brackets and remove any salt deposits that are stopping the thing from moving properly. This one's very smooth. We need to check that the engine tilts up and down smoothly. This one's in nice condition, no problem there. This little bracket that supports the engine is snapping into place nicely. Most outboard motors use mechanisms of this type. You just need to make sure that all the little pins and shafts move smoothly. If there's any tightness, dismantling them, removing the salt and then reassembling them with fresh grease is all that's normally required. The tilt rest pin is another item. This needs to be easily removable. This is quite an important component, as that pin dictates the angle at which the engine rides on the back of the boat. You can see this Johnson 4 has a choice of 5 positions, and to get the best performance from your outboard, it's important that this is in the correct hole to suit your boat. Only experimentation with your own boat will tell you which is the right hole. If we lower the motor down again, I can now check the thumb screws to see how smoothly they operate. They're very smooth indeed. This customer takes quite good care of this engine. So fortunately we're not going to have too much hard work to do with this engine. If these were very tight, you'd either have to completely remove them and recut the threads with a tap, although very often cleaning with a toothbrush and some petrol is enough to remove evidence of oil corrosion and free them off. I don't always like to use grease on thumb screw threads. Gearbox oil is much more preferable. Grease has a habit of collecting sand and grit, and if you're trying to use the boat with decent clothes on, you're going to end up covered in grease. The last thing I'll check on the saddle assembly for this engine is going to be the tiller arm. Very important that that moves nice and smoothly up and down. We need to check that the casting that it comes to rest against isn't broken, and we need to make sure that the tiller actually operates nice and smoothly. This drives the cable, which as you can see operates the stator. All of this is in nice shape on this engine. Any areas of tightness need to be dismantled, cleaned and greased as required. This engine has a friction device for the throttle. By screwing that in, the amount of effort required to turn the throttle arm is increased. This enables you to set the speed of the engine when trolling, and vibration won't cause that to shut. Again, this mechanism is working quite smoothly on this engine, but if there was any real tightness here, we'd have to again dismantle it, grease the offending component and remove any salt deposits. The next job for me to do will be to use the tray that I've pinched from my wife's kitchen. That'll catch all the drips. And then with my pot of petrol and paintbrush, I'm going to have a good look around the power head and clean everything that I can get to. Petrol's great stuff to use for this because it helps break down salt deposits, and at this stage, with nothing connected to the outboard, we can get to nooks and crannies that are not otherwise normally available to us. Once we've cleaned the outboard, we can have a careful look round at all the castings and the levers and other little devices on it to make sure they're all in good condition and none of them is broken or requires replacement. It's a good idea to use some of the petrol on all the little bushes that swivel, and that helps get rid of any salt deposits. The job I'd like to show you how to do now is a very simple one. Clean the drive shaft. Keep it over the drip tray. With your paintbrush, just give the shaft a little wash with some petrol and then some fine grade wet and dry. Gently polish the shaft up and down and you'll see the rust comes off quite easily. This is quite important because without doing this you'd have a great deal of difficulty in removing the water pump impeller. final wash, we can see that all the corrosion has disappeared. Now we can see the two gearbox screws here. This is the drain and this is the vent. If we undo these, we can take this opportunity to allow the gearbox to drain all its oil away into the drip tray. If we lay it over onto its side and left like that for 5 minutes, all the oil should drain. Let's have a look at the fuel pump. Here's the pump from this Johnson 4. This unit is used on an awful lot of OMC outboard motors, even Roods and Johnsons, up to 25 horsepower. The way it works is extremely simple. At the back we can see a little hole. If we look at the outboard, the fuel pump is mounted here. The top and bottom holes are for the retaining bolts. The centre hole goes right through to the inside of the motor. As the piston goes up and down in the bore, it creates fluctuating pressure, first positive, then negative. So in other words, there's a blowing and a sucking action through this little hole. That causes a diaphragm inside the fuel pump to go up and down. That in turn sucks fuel in through a valve and pushes it out of another one. We need to check this little pump carefully. It has quite a bit of work to do, especially if it's drawing fuel from a remote fuel tank, and they do wear out. The fuel pump from the Johnson 4 is quite a complex little item. If you're feeling brave, you can strip it. This particular item we have overhauled. If you do so, you need to make sure you take all the parts off the fuel pump in consecutive order, laying them carefully on a clean piece of paper and reassembling them in the same order. You need to look for damaged gaskets and diaphragms and corroded castings. Once it's reassembled, you can check its function by very simply blowing in through the fuel inlet pipe and ensuring that your breath comes out of the outlet pipe. There you could hear the little diaphragm working as I blew, but I can't suck back through it. That's indicating the valves are working correctly and fuel can flow through. We'll now fit this back onto the outboard. The carburetor. This is what does all the work for you, mixing fuel and air. A lot of things to check on this. Firstly, the butterfly. This enables the engine to accelerate in speed. It should open and close smoothly. If there's any stiffness, you're going to need to clean and oil the points on the body where the shaft goes through. If I operate it here, you'll clearly see the butterfly opening and shutting. At the other end of the carburetor we have a choke butterfly. That must also operate smoothly. The top here is the idle jet adjuster. This is set by screwing this in until you meet a slight resistance, and then you back it off 1.5 turns. At that point you'll be able to start the motor and fine tune it. This affects the engine's running up to about 1200 RPM. The next thing we'll do is remove the float bowl with the carburetor at this angle. Don't tip it upside down. Take out the screws, and we want to have a look at the fuel that's actually in the bowl. Be careful not to lose the fuel that's in there, because if you've had any running problems, this is the biggest clue you're going to get as to what the problem is. This carburetor has 4 screws holding the float bowl on. Once they're undone, carefully lift the carburetor off the bowl. Inside we have petrol. If there's any water in there, it will appear as lumps of jelly at the bottom of the bowl. Water is heavier than petrol, and it looks in all the world like a little blob at the bottom. This carburettor appears to be quite clean. We'll tip away this fuel, and then I'll show you how to clean this up. Now, there's a fair amount of sediment in the bottom of this carburettor. Very easy to clean. Simply blow it out with an airline. This is what the float bowl should look like once it's been cleaned. Now we move on to the carburettor itself. Remove the gasket, holding the carburettor upside down, and pop out the pin that holds the float in place. Carefully lift up the float, keeping your finger on the metal clip that holds the valve in place. You then need to carefully wipe the tip of the valve, hold it up to the light, and if you can see a groove where this seats into its base in the carburettor, then this should be replaced. This valve's in good condition and will see further service. If it fails, you'll have fuel flooding out of the carburettor and the engine won't run. At this point, this carburettor body should now be blown clean. We'll have a look inside this main jet, and then we can reassemble. The main jet will just unscrew quite easily. If we run the airline up this, have a look down through the jet. Providing you can't see any muck or obstacles, that's ready to be put back in. Use the airline to clean out the float valve socket and give the carburettor a general blow with compressed air to remove any debris or dust. Once everything's been cleaned, you can reassemble the carburettor's float by popping that back into its home. Carefully and gently pop the pin back through. It holds the float in place. And you can either use, if you have access to one, the float gauge tool. This is made by OMCs for this very purpose. And you can see the 2 to 6 horsepower section there shows you that that float is at the perfect height. That happens to be 16 millimeters. So if you have a vernier gauge, you can do much the same job. If it needs adjusting, you simply use some needle nose pliers at this point and bend it gently up or down till you achieve the right height between the end of the float and the carburettor body with no gasket attached. Everything's now ready for reassembly, so we put the gasket back on, which I've already checked for rips or tears, the cleaned float bowl, and then we do the screws up in an X pattern. We start in one corner, go across to the opposite corner, back to this side, and then across to here. Give each one a little pinch. Be careful not to over tighten. And that's ready to reassemble onto the outboard. Reassembling an outboard motor is just the reverse procedure of dismantling it. However, you should make sure that the nuts and bolts are cleaned and greased, and that any tight threads are tapped. That gets rid of any of the muck that will stop the threads from being stripped. When you're reassembling the gear case, great care needs to be taken to make sure that the gear shift lever goes through the hole in the gearbox cavity. This is a very fiddly job. I do recommend that the spark plugs are left out of any outboard that you're refitting the gear case on. That enables you to spin the flywheel, helping the splines on the drive shaft to engage easily. With the spark plugs in, you'll be fighting compression, and it may not be quite so easy to refit the gearbox. Gearbox oil should be refilled at this stage. The oil is put in from the bottom until it comes out of the top hole. This is to make sure that no air bubbles are left in the gear case. When you finish reassembling the motor, double check all the tightness of the nuts and bolts, and cylinder head bolts in particular should be torqued. Once this is done, you can then take the engine into the test tank, ready for its test run, tuning and winterization if required.